This is part 2 of Andrew Gallimore's Alien Information Theory, a book that he wrote back in 2019, or at least it was published in 2019. This is for educational purposes only. The views and writings of the author do not necessarily reflect my own personal views, but I may commentate on his writing as I have been doing with these videos anyways. It kind of occurred to me in from part 1 that I'm glad he um, defined the term information, but he did not define the term technology. As far as I can remember, he did not define that word. He kind of just assumes that everyone understands what he's talking about, and mostly for the most part, I would say that most people would understand what he means by technology. It's just I wish he would have defined technology. And if you're going to define it, the term information, then you probably should define the term technology as well. I believe the one statement he made was that DMT is a technology. If I remember the one line from like chapter 1 or chapter 2, he talks about how DMT is a technology and how like all this technology that we have is it's a profound expression of nature or something of that nature. And I'm just astounded that he makes such claims. I guess that's influenced by his DMT experiences, perhaps. I'm assuming that's part of the reason why he would make such a statement. But with that set aside, we should go to the text. We're on chapter 4, living information in a digital world. You can open your eyes and see all this world emerging out of nothing. What's that say? B-O. Looks like bong. Oh, it's boing. The eye is kind of, I can't really see the eye too well. With the, I have blue light blocker mode on my monitor screen, so it looked a little goofy for a second. Is it boing? Alan Watts. Is that a quote from Alan Watts? I guess this is the quote. Anyways, donning a virtual reality headset for the first time, it's startling how the pixelated digital landscape of early computer games have been superseded by entire worlds within which to wander and become lost. Excuse me. I'm getting hiccups again. Why do I get hiccups when I'm doing my readings? I don't know. Some water here. It's almost impossible to fathom how these immersive worlds of such dynamic and responsive complexity and beauty are built from binary code. The code is hidden, but the code is all. And although the immeasurably rich diversity of complex organisms that crawl, slither, and swim around our world seem to be animated by some magically vital principle beyond the physical, each and every one emerges in a hierarchy of complexity from the fundamental grid at the ground of our reality. To understand the structure of this reality, we need to examine with some care the structure of life. For although life feels somewhat disjoint from the cold, dark, and dead universe that surrounds us, even your own undeniable subjective reality is built from digital information. Everything is a manifestation of the complexification of information. Oh, baby. Holy cows. The complexification of information. That would be, I think that would tie into the definition of technology, complexification of information, because complexification of means is also tied into it. Imagine a society of social insects, such as an ant colony. A very large colony might contain several million ants, with different ant types providing specific roles in the organization of the society. The queen is the leader and founder of the colony. Her eggs fertilized by male drone ants. Female worker ants are responsible for maintaining the nest, as well as protecting it from intruders and predators. Each individual ant is a rather simple creature and interacts with the other ants in rather simple ways. However, the entire colony can display highly sophisticated behaviors, building elaborate networks of underground tunnels, delineating routes to food sources, defending against coordinated external attacks, or even forming themselves into bridge-like structures over water. No single ant directs the behavior of the colony, and no single ant, not even the queen herself, is aware of the overall structure or purpose of the colony. The colony self-organizes, and its behavior emerges from the myriad simple interactions of its members. This is Boeing again, only backwards this time. The complex behaviors displayed by the ant society only emerge when the society is functioning as a whole. These are emergent behaviors, which are a characteristic property of so-called complex systems, and can be defined as behaviors or properties exhibited by the entire system, but not by its parts. The whole is greater than the sum of its parts. Each individual ant behaves in a simple, stereotypical manner, but the entire colony exhibits sophisticated behaviors above and beyond that of any single ant. Although perhaps hitherto unnoticed, emergent behavior is everywhere. Anyone who's seen a flock of starlings, a murmuration, sweeping, twisting, and reconfiguring in elaborate dynamic patterns across an autumn sky can hardly fail to be astounded by its remarkably intelligent-looking behavior. However, the flock is not directed by any particular starling, and it's likely that individual birds mainly use their closest neighbors' local interactions to direct their movement in the air. Flocking behavior emerges not from the individual birds, but from the interactions between them. Just as there is no society program, quote unquote, encoded in every single ant within a colony, flocking is not programmed into the individual birds, the organization of birds into dynamic flocks or ants into complex societies emerges from the multitude of rule-based interactions between individual birds or ants. The flock does not need to be actively organized by a central organizer. The flock self-organizes. From these two examples alone, we can begin to delineate the essential properties of what are known as complex systems. A complex system is not just a complicated, chaotic, or random system, but one with at least four basic characteristics. One, many simple components, agents. 2. Local rule-based interactions between agents. 3. No central control. Agents interact locally with their neighbors or when they bump into each other, for example. 4. Self-organization and emergent behaviors. In the case of a flock of starlings, it's easy to spot these four features. The flock is constructed from many simple components, the individual starlings. These interact by observing and responding to the position and flight of neighboring birds, local interactions, and whilst there is no central bird controlling the flock, the birds self-organize and the beautifully dynamic behavior known as flocking emerges from this self-organization. Of course, not all types of birds demonstrate this flocking behavior. Self-organization is organization without an organizer, and if the rules are right, order comes for free. But the rules must be right. Not all systems with many interacting components, will exhibit complex emergent behavior. To understand why this is the case, we will return to our exemplar cellular automaton, the game of life. All cellular automata display the first three characteristics of complex systems. They are constructed from a large number of simple components. They are the fundamental cells that form the grid. Each of these cells interacts locally with the cells in their neighborhood according to a rule set. And like a flock of starlings, there is no central cell that controls the behavior of the automaton. All cellular automata are completely democratic. However, despite the obvious commonalities in their construction, not all cellular automata display what could be called complex behavior. The patterns generated by an automaton as it runs depend on its rule set, and the behavior it displays will always fall somewhere along a continuum of complexity. At one end is perfect crystalline order, and at the opposite is the entirely unpredictable, thoroughly disorderly behavior known as chaos. Mathematician Stephen Wolfram exhaustively studied the rule sets of many types of cellular automata and observed their behavior, noting that different rule sets often produce startling different behavior, but which falls somewhere on the scale. Wolfram defined four distinct types of behavior. Class 1, a fixed, unchanging pattern eventually emerges. Class 2, a pattern consisting of periodically repetitive regions is produced. Class 3, a chaotic, apparently random, aperiodic pattern is produced. Class 4, complex localized structures are produced. Class 1, Class 2, Class 3, Class 4. This looks like QR codes, man. Anyways, we met these categories less formally in the last chapter when discussing the different behaviors of elementary cellular automata, but let's look at them more closely. Class 1 cellular automata may display early flurries of activity, but this soon settles into an unchanging pattern with all cells remaining at the same state. Class 2 automata are characterized by repeating patterns that are slowly more interesting but highly ordered and non-complex, whereas Class 3 automata displays a tumult of chaotic behavior but that never settles. Complexity, the domain of the Class 4 automata, is neither order nor chaos. but sits in a narrow band between Class 2 and Class 3 behavior known as the edge of chaos. This special region is where complexity reaches its maximum before descending into chaos, and it is only within this narrow band of the complexity continuum that stable propagating structures such as gliders and spaceships can emerge and remain stable. A complex system maintains a type of order, but it is not a static order unresponsive to the environment. It is a dynamic order. A flock of starlings holds together as an ordered structure which we can recognize as a flock, whilst remaining fluid, dynamic, and ever-changing. This is the hallmark of a complex system at the edge of chaos, where order and disorder are critically balanced. I feel like there might be some hermeticism principle in here somewhere. Isn't that one of the principles, the principle of balance? And anyways, the game of life exemplifies this type of complex behavior. As the game runs, the grid begins fizzing with a diverse range of critters, virtual state machines, and that propagate around the grid and interact with each other. Some of these first-order virtual state machines may join together to form higher-order virtual state machines, and eventually the grid is transformed into a dynamic ecosystem, quote unquote, of virtual state machines at varying levels of complexity. Although each individual cell of the grid is relatively unsophisticated, the emergent behavior of the system as a whole is exquisitely complex and unpredictable. Simple rules can give rise to highly complex behavior. However, although the patterns emergent on a game of life grid are certainly fascinating, even lifelike, it's not difficult to appreciate that they emerge from the rule-based computations of the individual cells of the grid. As such, the game of life offers us a clear example of the complexification of information. The critters that emerge on the grid are built from information instantiated by the states of individual cells, and as these critters appear to move about the grid, it is actually information that is moving. This flow of information across the grid, instantiated by the rippling of gliders or other structures, is critically important for generating the complex behavior that distinguishes the game of life from non-complex automata. A little sip of water. The critters that emerge on the game of life grid fall into a number of categories, with the simplest being the static numbers known as still lifes. Whilst these might be interesting to a limited extent, a grid populated entirely by still lifes could never be described as complex. Still, since still lifes have no way of interacting with each other, ever remaining islands irrevocably separated. However, it is the dynamic propagating critters that allow complexity to emerge. As these gliders, spaceships, and other dynamic critters scuttle across the grid, they can interact directly by colliding with each other, or indirectly by emitting projectiles that interact with other critters in their path. As in all complex systems, these interactions between the critters, the agents of the system, engender the emergent complexity. In the case of the game of life, it is the interactions between moving patterns of information complexes, that generates the complex behavior. And here's some of the critters I think he's got going on here. So this is like a type of grid that he's got in the background. I would imagine since these look similar from the diagrams he had earlier. Anyways, whether a particular cellular automaton exhibits complex behavior will depend to a large extent on whether or not it can generate such stable but dynamic patterns that interact and transmit information around the grid. A Class 1 automaton, which remains unchanging over time, is obviously unable to generate such patterns. A chaotic Class 3 automaton is equally unable to transmit information. Any structures that form are transient, quickly disintegrating as the information they encode dissipates into the seething sea of chaos. Now, if one remembers the word dissipation from Robert Temple's A New Science of Heaven, where Prigozhin's talking about dissipative structures, this is not the same thing. This is definitely not using the word dissipation in the same sense as Prigozhin used it for self-organization happening among plasma, dusty complex plasmas. How these connect, I don't know. Um, Gallimore seems to be talking about a more fundamental substrate than plasma. Anyways, they as the information they encode dissipates into the seething sea of chaos. But in Class 4 automata, at the edge of chaos, the stable structures can emerge and maintain their form as they glide across the grid, carrying the information they both encode and indeed are built from. So Class 4 automata can be distinguished from their less interesting Class 1 to Class 3 cousins by the way information flows through them, allowing stable patterns not only to emerge, but to interact. The stable, propagating, and interacting virtual state machines that characterize the game of life form a complex system at a level above the base of the grid. The individual cells are, of course, unmoving, with a static and unchanging set of neighbors with whom they can interact. In this sense, all cellular automata are completely static. Only the states of the individual cells change over time, with each parallel update of the automaton. It is only the information instantiated in these cell states carried by the virtual state machines that flows about the grid. The virtual state machines form a system of interacting agents at an organizational level above, but emergent from the fundamental static agents, the cells, at the base of the grid. And this can occur at many levels of an organizational hierarchy. Information complexifies upwards with new complex systems of interacting patterns of information merging at higher and higher levels of an organizational hierarchy, the formation of each driven by the flow of information between these patterns and through the system. In non-complex Class 1 to Class 3 cellular automata, this complexification never progresses above level of the base grid. This same principle applies in our universe. In even the most complex of structures, including conscious living organisms, no objects really move in the universe. Patterns of information merge instantiated by the cell states of the grid, and this information flows between cells, generating the patterns of information that self-organize to form the higher order patterns we recognize as atoms, molecules, cells, living organisms, and the patterns they form, whether it be a flock of starlings, a society of ants, or human civilization. Okay, maybe there's the tie-in with Prigozhin. The base of the grid doesn't have it's. If I'm understanding this correctly, the classes 1 through 3 can't are not dynamic enough to make higher and higher hierarchies or levels of complexified information. It's only the class 4 that does so, and that seems to be the tie-in to how dusty complex plasmas start to self-organize and continually build up more and more complexification, if I'm understanding this correctly. But he's not using that word dissipative like Prigozhin would. So that's, but I guess that's neither here nor there. Describing the thing happens, whether people describe it with certain terms and phraseology is another matter. Anyways, where was I? The layered complexification of information instantiated by the grid generates all the forms we observe in the universe. The difference between our universe and the game of life grid is that this layered complexification has progressed much higher in the universe, with a deep organizational hierarchy emerging, with living organisms sitting at the apex. All complex systems can be recognized as self-organized emergent patterns of information. What we recognize as objects, quote unquote, taken with the names we use to label them, are merely descriptive conveniences that allow us to describe and distinguish all the different patterns of information at varying levels of complexity that are emergent on our universe grid. That's basically kind of what I said just a minute ago. These labels, whatever terms or names we label them, it's just descriptive conveniences for us. So what about life? It shouldn't come as any surprise that living organisms are rightly categorized as complex systems, and as such are most accurately viewed as highly complex patterns of information processing. Life is an emergent behavior of certain complex systems. Living things must, of course, maintain a degree of order, otherwise they couldn't exhibit the complex, meticulously organized functions characteristic of living organisms. Excuse me. However, this order must be balanced by a certain degree of flexibility, since a rigidly ordered system would be unable to respond to information from its environment, process information in novel ways, make decisions, or evolve over time. Too little order and life breaks down, but too much and life cannot form. As with other complex systems, life can only exist in that narrow band at the edge of chaos, where order and disorder are critically balanced. But life seems like a very special type of complex system, and indeed, life has particular properties that allow us to define it as such. The patterns of information referred to as living organisms sit high within a stack of layers of increasing complexity. It said conked out the first time, hopefully not too many times after this. Where was I? Just had to start over. The patterns of information referred to as living organisms sit high within a stack of layers of increasing in complexity. At every layer of a hierarchically organized complex system, we can observe emergent behaviors not exhibited by lower levels, with emergent behaviors at one level allowing new, even more complex behaviors to emerge at even higher levels. Life represents the pinnacle of this process of self organization and the complexification of information taking place on the grid of our universe. Life is a special type of emergent behavior that only appears at the highest levels of an organizational hierarchy, built upon many layers of diverse emergent behaviors below it. But what exactly is life? That's a very good question. Let's try to define it, right? I mean, if it's even definable, that's another story in and of itself, I suppose. Most people would feel fairly confident in distinguishing something living from something non-living. Birds, spiders, plants, and bacteria appear obviously alive, but pinning down a precise definition of life, quote unquote, is more tricky. Perhaps the pithiest definition came from biologist Umberto uh, Maturana and Francisco Varela, who posited that living organisms are distinct from non-living machines in that they are autopoietic, meaning self-creating, quote unquote. Oh dear, what in the world is this? Interactions between simple agents cause higher order structures and behaviors to emerge. Higher order emergent structures. Oh, it's like not connected. This little triangle just disappeared. Then these things was going isolated simple. Oh, if you go the complexity going upward. Okay, so you have these base units, and then they get connections and forming higher and higher complexity, right? Okay. Although a glider on a two-dimensional cellular automaton is certainly not alive, the glider maintains its identity despite its constituent cells changing every few time steps. Similarly, living organisms are not objects as such, but patterns of information that maintain and regulate in themselves over a period of time we recognize as a lifespan, which might be a few days or several decades. The simplest organism recognized as living is a single-celled organism, such as an amoeba. Although throughout its short life, every single component of the amoeba might be degraded and replaced several times, it still maintains its identity as an amoeba. It it achieves this by virtue of its construction from complex networks of interacting components that maintain themselves despite individual components breaking down. As old components of networks degrade, other networks act to replace these components. So the entire system regulates, maintains, and regenerates itself. Put simply, in words of physicist Fritjof Capra, quote, life is a factory that makes itself from within, end quote. Oh dear. Three of these things, and I don't know what's going on here. The process of self-maintenance, regulation, and regeneration is an emergent behavior of highly complex type of information processing. This behavior emerges from the interactions of large numbers of simple components. So a living organism is not a large complex machine so much as a system of smaller and simpler machines, which are themselves patterns of information. It is the interaction of these small machines that produces the complex behavior of living organisms, and fundamentally, these interactions are the flow of information through the system. You should be able to see the relationship between the emergent behavior of a flock of starlings, or a colony of ants, or a living cell, which one might go far as to call a quote flock of molecules, end quote. In general, a living organism is a complex, hierarchically organized pattern of information that maintains, regenerates, and replicates itself over time. Okay, there's his working definition. Wish I could highlight with this, but I guess not. If a cell were large enough for you to open it up and peer inside, you would find it packed with small molecules swimming in the gel-like interior, interacting with other molecules and building new ones. Like all complex systems, cells are built from a large number of simple components: proteins, sugars, lipids, DNA, etc., that interact with each other. Whilst the individual interactions between components are relatively simple, it is from these interactions that highly complex behavior emerges, building and maintaining the structure of the cell, absorbing and processing nutrients from the environment, excreting waste products, moving away from toxins and towards food sources, and even splitting to form new cells. The complex behaviors of the entire cell emerge from the multitude of interactions of the simple components, and it is these emergent behaviors that together produce an autopoietic system that we consider to be alive. Of course, in multicellular organisms such as ourselves, large numbers of cells can self-organize uh, to form even more complex structures, such as muscles, hearts, and brains. In the human body, we can see a number of higher levels of organization. Cells self-organize to form tissues, tissues self-organize to form organs, and organs self-organize to form the complete organism, with new emergent properties emerging at each layer of the hierarchy. Whilst a simple cellular automaton, such as the game of life, could never be considered alive, the behavior of these class 4 automata is useful in revealing how simple rules can give rise to complex, hierarchically organized patterns of information. Despite having only two cell states, dead or alive, the game of life displays a striking level of complexity, with a multitude of critters merging and scrambling across the grid. As they interact, these first-order critters, via virtual state machines, can self-organize to form high-order structures with emergent computational capacity, some of which begin to emit, construct other critters. These new critters uh, become, why is that separated? These new critters become part of a diversifying ecosystem, themselves interacting with other critters to form novel high-order critters. Eventually, the grid begins frothing with an increasingly complex and diverse array of critters interacting with each other in increasingly complex ways. It is not too much of a stretch to imagine how autopoietic and thus living structures might eventually emerge from this sort of rich biochemical quote unquote soup. Why is there a dash here? I don't get it. Is this like typos? Probably not. The game of life will always remain on the first few rungs of the ladder of complexity, whilst our universe has progressed much higher and most likely will continue to do so. Hmm. Despite sitting at very different levels of the organizational hierarchy, both our universe and the critters in the game of life emerge from information processing. In the case of the game of life, it is the cells of the automaton grid that perform the computations, whereas in our universe, it is the cells of the grid. Did it again. This is the third time. Uh, This picture of living organisms as autopoietic systems of hierarchically self-organized patterns of information is comprehensive but not yet complete. Living organisms don't exist in a vacuum, but rather embedded in an environment. In fact, they are both built from the same stuff as the environment and fully develop upon it. From an organism to remain alive, it must depend upon a flow of molecules and energy into and out of its cells, which we recognize as food, oxygen, and waste products. From the informational perspective, it, this is nothing more than the flow of information from the environment into the network of interacting patterns of information inside the organism. Pause. Okay, where was I? I think I was on this paragraph. This picture of living organisms as autopoietic systems of hierarchically self-organized patterns of information is comprehensive, but not yet complete. I did read that. Food, oxygen, and waste products. Yacht, doopy doop. For example, embedded in the membrane of all cells are specialized proteins called receptors, which are charged with transmitting information across the membrane from the environment into the network of proteins and other molecules inside the cell. I guess this is a cell. Yeah, a cell is a self-organized emergent structure built from a large number of simple interacting components, each of which is itself a excuse me, each of which is itself a self-organized structure with emergent properties. Excuse me, getting these damn hiccups again. A receptor spans the entire membrane with an outward-facing domain exposed to the environment, and an inward-facing domain exposed to the cell's interior. The outer domain binds selectively to molecules in the environment, with different receptors binding to different molecules. Upon binding to the receptor, the molecule causes the receptor to twist out of shape, distorting both its outer and inner domains. The altered geometry of the inner domain allows it to bind to molecules inside the cell known as signaling proteins, which are themselves part of the complex network of molecules inside the cell. So overall, the overall, by binding to the receptor, a molecule outside the cell transmits information across the membrane and into the cell. By sporting a variety of different receptors in its membrane, each binding to a specific type of molecule, in the external environment, a cell can receive a variety of forms of information about the environment. It's not difficult to see why this could be useful. It's not difficult. It might, for example, allow a cell to detect sources of food or toxins, chemical signals secreted by predators, or even to distinguish between light and darkness. Hmm. We got this exterior is on the top side, interior on the bottom side. Receptor to the outer domain comes in. Yep, downstream signaling molecules. Oh dear, what is this? All the interactions between the molecules, I guess. When a molecule binds to a receptor protein, information is transmitted from the environment into the cell, where it spreads through and is processed by the network of molecules in the cell's interior. You know what? This kind of reminds me of what Robert Temple was talking about in his book about the death flash, about the how all the cells get the signal and they all start and apoptosis occurs. You know, cell death. So I guess the signal is information itself, I suppose. It's kind of crazy to think about it in these terms, I suppose. The binding of a molecule to a receptor protein exemplifies one of the most important concepts in this book, perception. In humans, perception is commonly defined as the process by which awareness of the world is achieved via the senses. The detection of light by the eyes, of sound vibrations by the eardrum, for example. Uh, Although we will eventually discuss how your brain is able to perceive orthogonal dimensions of reality during a DMT trip. Yeah, but I thought this book was about DMT trips. You're talking about these like virtual state machines and quantum numbers and automata, and I'm hoping there's like it ties in to some degree. I mean, I would imagine it does, or else he wouldn't be writing about it unless he was like a true nerd or something. Anyways, we must first think about perception more generally and on a more fundamental level. Perception is usually described as a means of sensing the environment and is typically restricted to organisms that either presumably that are either presumably conscious or that at least possess a nervous system. However, it will be helpful to define perception more generally as the process by which a structure, living or otherwise, receives and processes information from its environment. A receptor embedded in a membrane enables a cell to select information from the environment and to transmit this information across the cell boundary and into the network of molecules inside the cell. This is perhaps the most basic form of perception of which all organisms must be capable. An organism will not survive for long if it cannot receive and process information about its environment, which is the basis of perception. A system of receptors embedded in a cell membrane, each specialized to receive and transmit a specific type of information, allows an organism to thrive within an ecosystem of other organisms competing for food and other resources. For example, receptors that bind glucose molecules can provide information about the location and concentration of this important energy resource. Similarly, receptors for toxins, pheromones, or other significant molecules provide an organism with a kind of chemical map of the environment with concentration gradients of specific molecules mapped out by their differential activation of receptors on different parts of the cell membrane. Of course, it isn't necessary for the molecules themselves to pass across the cell membrane, only that they bind to the external domain of the receptor, such that the information signaling is present. Uh, their presence is transmitted into the cell. Let me start. Can I redo that? Only that they bind to the external domain of the receptor such that the information signaling their presence is transmitted into the cell. This system of receptors allows the cell to continuously receive information from the environment, which can then be processed by the network of molecules inside the cell. Naturally, this information is only useful if the cell has the machinery to make sense, quote unquote, of it and to respond in a functionally useful manner. This requires not only perception, which we can also call sensory input, but also a means of producing a response, which is the output. This response might be rather simple and automatic, such as moving up a concentration gradient towards a food source or away from an area with a high concentration of toxins. However, whilst such stereotypical responses might be sufficient for a single-celled or organism, a multicellular organism perched several layers in organizational complexity above such amoebic simplicity, requiring of a constant and intensive supply of nutrition, and with the constant threat of being preyed upon by other complex multicellular organisms, this would never do. The more complex an organism becomes, the greater is its need for a rich real-time supply of information from its environment. And not only must they supply uh, and not only must this supply be abundant, but if the response in any given situation is to be appropriate and effective, this information must also be filtered and processed. As an organism evolves towards greater and greater complexity, a specialized structure with the sole purpose of receiving and processing information from the environment becomes a necessity. Of course, this is what we know as a brain asterisk. I think that's an asterisk. It's really tiny thing. The biological information, the biological information generator and processor par excellence. The brain is, I guess, he's saying. As brains evolve and complexify, they begin to construct elaborate models of the environment containing a wealth of information pertinent to the organism's survival. eventually an information-rich subjective map that constitutes the personal reality of an individual organism emerges. The organism wakes up in a world. Asterisk, we will often refer to the structure that performs the function of a brain more generally as a brain complex, a type of information complex, since such structures are universal features early of complex life, whether earthly or otherwise. Quote, if the outside world fell in ruins, one of us would be capable of building it up again, for mountain and stream, tree and leaf, root and blossom, all that is shaped by nature lies modeled in us. End quote. Herman Hesse. Another QR code looking thing. Chapter 5, Waking Up in a World. Your brain is the most complex structure in the known universe, effortlessly manifesting the rich and lucid tapestry of your world from moment to moment. As you witness this glorious unfolding of the world from behind your eyes, you'd be forgiven for losing sight of its fundamental nature as information generated by your brain, which is itself an information complex instantiated on the grid. Hold on a second. The way you word things, where was it? Your brain, you as a self have a brain. You're the object you're possessing is your brain. Is the most complex structure in the known universe. That's a tall claim. I mean, clarifies the no, putting the modifier known on to the universe. So he's not saying all of the universe, only the universe that we currently know about, which to my opinion is not that much. We don't really know much about the universe, and as far as I'm concerned, it's a huge place. So a huge state, perhaps too. Um, I don't know where I'm going with this. Where else? What else did he say? As you witness this glorious unfolding of the world from behind your eyes, let's back up a little bit here. Effortlessly manifesting the rich and lucid tapestry of your world from moment to moment. So the brain is doing this. So as you witness this unfolding, as you witness this manifestation of the rich and lucid tapestry, so you as the self are witnessing what your brain is manifesting. So that's two different objects, you and the brain. So I don't know. I think that's kind of interesting how he words it. I mean, he doesn't explicitly say self, but it's kind of implied in the you and your. Anyways, each of us lives out each of our lives from behind our eyes in a world that French philosopher Pierre Teilhard de Chardin has entered the chat, called the quote uh, within of things, end quote, quote, the object of a direct intuition and the substance of all knowledge, end quote. It's not enough to say that your body and your brain is built from information. For for conscious beings such as ourselves, borrowing from philosopher Thomas Nagel, there is something it's like to be something it is like to be this particular configuration of information. There is a within, and this within is your phenomenal world, the world of subjective experience, and the only world you can ever know. Oh boy, I guess Kant has also entered the chat too. Um, Whether you are hurrying down a damp street on a gray Sunday afternoon, a Sunday morning rather, excuse me, or dancing with ancient gods in a jeweled temple with bizarre crystalline geometries of immeasurable luminosity and form. It is always your own personal world, and it is always built from information generated by your brain. I did have a dream once where I was not necessarily dancing, but I was interacting with Egyptian gods, I think, in a pyramid structure. I don't remember all the details, but it was kind of strange. Anyways, ancient. He doesn't say Egyptian god. He just says ancient gods in a jeweled temple. So he doesn't say pyramid. But anyways, that's what it just made me reminded me of that dream. Anyways, he's putting a lot of emphasis on your brain. If we are to understand the bizarre world visited at the peak of a DMT trip, we must first understand the more prosaic world of your daily life in this universe, its purpose, why it takes the form it does, and its relationship to everything happening out there in the so-called external world. Yeah, I think Kant has entered the chat, it seems. Numina, the thing in itself. Transcendental idealist. Oh, yeah, there he is. Transcendental idealist Immanuel Kant distinguished between the phenomenon, the subjective world within each of us lives, and the noumenon, the unknowable world in itself, independent of our perceptions. Your brain is a high level information complex that generates the information that is your phenomenal world. This is the phenomenon. The noumenon is all the information being generated by the grid. The world in itself is information. Bro. The world in itself is information. I mean, this basically saying the Matrix without saying the Matrix, basically, right? Say that the world, the universe is information. The universe in itself, the world, obviously world, not meaning the planet, but the whole state of things, the whole of reality, the universe, all possible worlds. Not That's probably what he refers to, especially talking about Kant. Um, so yeah, your brain generates a highly complex form of information that has the special property of subjectivity. You experience this information as your world, whether you are awake, dreaming, or at the peak of a DMT trip. Of course, although your phenomenal world is always built from information generated by your brain, we will discuss later how your brain achieves this. Yeah, so I want to see how you get into that. There is an undeniable relationship between this subjectively experienced world and the world outside of your brain, which we would naturally call the environment. Your brain evolved as a generator, receiver, and processor of information. More specifically, it evolved to receive and process information from the environment, the surrounding grid, and then to make judicious decisions regarding behavior based on the results of its computations. In the last chapter, we defined perception generally as the receiving and processing of information from the environment. A single cell perceives its environment via the gamut of receptors embedded in its surface. The information flowing from the external world to the networks of signaling molecules in its interior. The information flowing from the external world to the networks of signaling molecules in its interior, organized at a much higher level than the individual cell. Your brain is a perceiver par excellence, not only receiving information from the environment via the sensory apparatus, but also using this information to generate a model or map of this environment. The world you live within, the world you live within is this model. Hmm. Brain complex environment. You, the world you live within is this model. It's not quite solipsism because the brain is allegedly taking information from the from what is exterior to your brain, at least from what he's saying. Reminds me of something else. I remember, what was it? Talking to someone and how the brain compartmentalizes all the sensations: seeing, smelling, tasting, touching, hearing, as in like unpacks them and separates them into different senses. I forget I don't know what I'm talking about. Um, yeah, the brain is an information complex specialized in receiving and processing information from the environment surrounding grid. It uses this information to build a model of the environment. If you look around you now, you will see a world rich in information. All the objects, colors, textures, relatives, distances, and values associated with all these things, beauty, disgust, ambivalence, etc., are encoded by information generated by your brain. Your world is entirely that information experienced from the inside, from within. And there, ergo, as within, so without, as above, so below. I don't know, maybe. Your brain generates this information not because it will afford you a beautiful world to enjoy, but because the phenomenal world thus manifested is useful to you and for your continued survival. A world that a world that contains useful information about the ongoing activity in the surrounding environment provides an organism with an evolutionary advantage over those organisms unable to build such a world. The grid contains a multitude of information complexes with varying levels of complexity. We recognize these as other organisms and inanimate objects, but let's not lose sight of their true nature as emergent structures built from information. Some of these complexes contain information either beneficial or essential to an organism, which we might recognize as food or sunlight, and some contain information harmful to an organism. Predators, for example, are other organisms that take an active interest in destroying us because they consider us food. However, there are more subtle forms of information. The distances between objects enable us to navigate the grid to seek certain types of information whilst avoiding others, for example. All of this information is encoded within your brain and forms a model of the external world, sculpted over millions of years of evolution. As a brain evolves, so does the world that it generates. Hmm. The random changes that occur at the genetic level during reproduction can increase the chances that an organism will successfully survive and reproduce. These are called adaptive changes. For example, a slightly longer beak might enable a bird to reach insects embedded more deeply in the trunk of a tree, giving that bird an advantage over birds with shorter beaks. This well-fed bird will be more fertile and give more likely to produce a number of strong offspring. Changes can also disadvantage an organism and make it less likely that it will successfully reproduce. These are non-adaptive changes. This process of evolutionary change also applies to the phenomenal worlds built by our brain. As a brain evolves towards increasing complexity, it becomes capable of building more and more complex phenomenal worlds containing more and more sophisticated information about the surrounding environment, as well as being able to process and make decisions based on this information in more sophisticated ways. Organisms with brains that generate poor models of the world, perhaps models that fail to distinguish between predators and prey, will be less likely to survive and reproduce than those with brains that generate adaptive models. Imagine a primitive brain that is little more than a random information generator receiving. That's number two for headset conking out. Let's start here. Receiving and processing very little information about the environment. Whilst this brain might generate a sort of phenomenal world, it is likely to be a highly unstable and chaotic world that could in no way be described as a model for the environment of the environment. In other words, the information being generated by such a brain tells the organism almost nothing about the information being generated within the environment. And what is generating the information in the grid is, in his model, I suppose, the amount of information shared by two variables, in this case, a brain and the environment, is called mutual information and is a measure of how much we can learn about one variable by knowing something about the other. For example, if you show me a photograph of a pair of identical twins without seeing the other, I already have information about the other twin, the color of their eyes, the shape of their nose, etc. The twins share mutual information. The mutual information between this primitive brain and the environment is very low. Even if you had access to all the information being generated by the brain, you would learn very little about the information being generated in its environment. As a brain evolves and its continual world changes, it begins building worlds that contain more and more useful information about the environment. In other words, the mutual information between the brain and the environment increases. Of course, building useful models of the world is not simply a matter of accruing more and more information. A brain must be selective, ignoring irrelevant information and selecting pertinent and useful information. In fact, this filtering of irrelevant information as is as important as the selection of useful information. More is not necessarily better. You know what this kind of reminds me? This kind of reminds me of Thomas Campbell, where he's talking about the evolution of consciousness being like the main thing about macroevolution or something. Maybe I'm not explaining it very well, but I don't know if that's something worth looking into per se, but this definitely reminds me of it. What little I know of his position, Thomas Campbell. I mean, psychedelic drugs, including DMT, and certain psychiatric conditions modify the phenomenal world by modifying the information generated by the brain, creating an alternate model of reality. However, we mustn't make the mistake of assuming that the normal waking world in healthy people is somehow the only true and or valid reality. All models of reality are equally real in that they are all built from information. Process of brain evolution going downwards, at least on the paper, on the page anyway. Information generated by the environment. It's this giant cube of QR code looking thing. So much QR code looking things in here. Information generated by the brain, which is less. Oh shit, son. This is like totally detached from reality. This is starting to emerge into to not emerge with reality, but to understand reality, to attach to reality, and this is like mostly attached, I guess. As the brain evolves towards increasing complexity, the mutual information shown in blue between the brain's model of the world and the environment increases. So, doop. Of course, some models will be more or less adaptive than others, depending on the relationship between the model and the environment. A schizophrenic's world, for example, might well be markedly different to that of the ostensibly sane majority. We can't, however, say that the schizophrenic's world is less real, quote unquote, than anyone else's world. Only perhaps uh, that is less only perhaps that it is less adaptive, containing less useful information about the environment and more information unrelated to it. There is less mutual information between the schizophrenic's brain and their environment. The same applies to the altered worlds elicited by psychedelic drugs, which modulate the information generated by the brain and change its relationship to the environment. This change might be subtle, as with a threshold dose of psilocybe mushrooms. I don't know if I'm pronouncing that right, or extremely profound, as with a breakthrough dose of DMT. Schizophrenic. What was I thinking to say? Something about schizophrenia. Well, it's very possible that what for unfortunately diagnosing someone as schizophrenic, that doesn't, if you want to say the world that's generated by the schizophrenic's brain is not any less real, quote unquote, than the rest of us who are not schizophrenic. That doesn't necessarily mean the schizophrenic is crazy in the sense that there might be something there might be something in the environment that is causing or that is generating and uh, perhaps planting information into the schizophrenic's brain. So, I mean, aliens maybe, but interdimensional beings, I mean, who knows? It doesn't necessarily mean that they're just crazy just um, because of their brain not working right or whatever. But I'm not an expert. I'm not trying to give any medical advice here. It's just solely my opinion. Um, Anyways, in summary, your normal waking phenomenal world is a model of the world that your brain has evolved to facilitate your survival as a complex pattern of information on the grid. Your brain, just like the rest of you, is a highly complex, hierarchically organized structure built, like all things, from information, although it sits at the apex of the known hierarchy of complexity. Although all strain, although all structures generate process and are built from information. A brain is special in that it generates information that manifests as your phenomenal world, your personal reality. Whether you are awake, dreaming, or tumbling through the elfin playgrounds after two lungfuls of thick DMT vapor, your journey, your personal reality is always built from information generated by your brain. Although these worlds might be very different in structure and in terms of their relationship to the environment, they are unified by their fundamental nature, information. Bzz, beep boop. The one square. This is the next chapter, chapter 6. How are we doing? I think I'm just going to end it here for now. So